हेलो एवरीवन। सो द टॉपिक इज सीक्वेंस एंड सीरीज। बहुत ही सुंदर और बहुत ही प्यारा टॉपिक है। क्यों है ऐसा? क्योंकि हम इससे इंट्रोड्यूस हो जाते हैं शुरू से। जब हम बचपन से पढ़ना चालू करते हैं तभी से हमें सीक्वेंस सीरीज के बारे में कुछ नॉलेज मिलता है। क्लास 10th में जाकर हम इसके बारे में थोड़ा सा और विस्तृत नॉलेज, वी गेट अ ब्रॉड व्यू अबाउट अ सीक्वेंस सीरीज प्रोग्रेशन इन विच वी स्टडी अबाउट द arithmetic progression. Now what we are going to cover in this is we are going to cover AP, GP, HP, AGP and some special series. So let's start with sequence and series. So how we will define a sequence? So sequence is a set of all the terms which are defined by a certain particular rule or a particular pattern. That is, the terms will follow a particular pattern or a particular rule. And when we will talk about how many terms this sequence has, so sequence always has the natural number of terms. That is, we will either having at 5 terms, 10 terms, 15 terms. So the domain will be the n natural number of terms. Now let's define some sequences. So in our primary classes also we have studied about the terms like so is this a particular sequence? Yes, it is a particular sequence. Why? Because this is a sequence of the square of the natural numbers. Similarly, if we are having some sequence like 1, 8, 27. So is this a particular sequence? Yes, it is a particular sequence because the terms are this is 1 cube, this is 2 cube, this is 3 cube. So a sequence must follow certain particular order. Now, what is a real sequence? When we talk about a real sequence, then the subset of all the terms, that is the subset is a real numbers. That is, the terms in the sequence are all real numbers. Now let's see some real sequences. So for example, if we have a sequence like this, that is 2, 5, 8, 11. So how we are going to get that it is a sequence? So first and the foremost thing is sequence must follow some particular order. So is it following some particular order? Is it following some definite rule? So here we can see that if we are subtracting the second term by first term, we will be getting 3. Again, if we are subtracting the third and the second term, we are again getting 3. And here 11 minus 8 is again 3. So we can see here that the particular pattern is if we are adding 3 to the previous number, then we are getting the next number. So we know that what type of sequence is this? This is an arithmetic progression. Now, second will also follow some particular order. Here we are subtracting 3. So all these terms are real numbers. So this is a real sequence. Similarly in this also, what we are doing here? We are multiplying it by minus 3. So 3 into minus 3 is minus 9, and then we will multiply it by minus 3, we will be getting 27, and then if we will be multiplying by minus 3, then the next term will be minus 81. So a sequence is following a particular order and all these terms are real numbers, so this is called a real sequence. Now, we are having the two types of sequences. These are finite sequence and an infinite sequence. In a finite sequence, the number of terms are finite, whereas if we will talk about an infinite sequence, then the number of terms are infinite in it. So a finite sequence is having finite number of terms and an infinite sequence is having infinite number of terms. For example, if we will see, then the terms like 1, 2, 3, 4, 5, first 5 natural numbers following the order that adding 1 we will get the second, and if we are having like 1, 2, 3, or we can say 2, 4, 6, 8, 10 and dot 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 dot, that means it is an infinite sequence and it is following the order that the every term is added by 2. Now let's solve some question. Now we are asked that determine if this pattern represents a sequence or not. So what is the sequence? Again we are going through it that the sequence must follow a particular order. So is it following? क्या ये हमारा किसी particular order को follow करता है? तो हम देख लेते हैं कि क्या सर ये किसी particular order को follow करता है. So हमारे पास पहला term 0 है, then हमारे पास 1 है, then हमारे पास 1 है, then 2, 3, 5, 8. अगर हम ऐसे देखेंगे तो ऐसा लगेगा कुछ रैंडम से नंबर्स लिखे हुए हैं, बट इफ वी विल सी देन व्हाट हैपनिंग हियर इज 0 plus 1 gives us 1, 1 plus 1 gives us the second term 2, 2 plus 1 gives us the next term 3, 3 plus 2 will give us the next term 5, 5 plus 3 will give us the next term 8. So yes, it is following a particular pattern. And if we are asked that what will be the next term, so what we will do here? 8 plus 5. So what will be the answer? 13. So 13 will be our next term. So we can say that yes, it represents a sequence. Now, moving to the next thing. Now let's talk about what is a series. So series and sequence are differentiated by, in a sequence we write the terms by comma separated values, and in a series we either add these terms or we subtract these terms. So that becomes a series. For example, if a1, a2 and an, these are all the terms of the sequence. This is the first term of the sequence, this is the second term, this is the third term, and this is the nth term. So these are comma separated values, this is the sequence. And then if you will use addition sign or subtraction sign, if you are adding the terms or you are subtracting the terms, then it becomes a series. Now these are some basic examples. So we can see here, this one is a finite series, and this one is a infinite series, because we are not given that to which number it is ending. So it is an infinite series, and we can see here the terms are being added to each other. Now, what we are told, we are asked in this question to write down the series whose nth term is given by this particular pattern. So nth term we can write as Tn is 1 upon n square sine n pi by 3. So T1 will represent my first term. So in place of n, what we are going to put, n की जगह पर हम रख देंगे 1. जब हम n की जगह पे 1 रख देंगे तो हमारे पास फर्स्ट टर्म आ जाएगा. In place of n, when we will be putting n equals to 1, then we will be getting the first term. So that is 1 upon 1 square sine pi by 3. So 1 upon 1 square will be 1, and sine pi by 3, we know that its value is root 3 by 2. To find the second term, what we will do? We will write T2, n equals to 2. So T2 will give me value 1 upon 2 square sine 2 pi by 3. So 1 upon 2 square, that is 1 upon 4, and sine 2 pi by 3. So we already know that from trigonometry, sine pi minus theta is same as sine theta. So sine 2 pi by 3 can be written as sine pi minus pi by 3, and sine pi minus theta is sine theta, so that will be sine pi by 3. So sine pi by 3 is root 3 by 2. So this will be root 3 by 8. Similarly, we can find more terms. Putting n equals to 3, n equals to 4, we can find third term, fourth term. Now, let's talk about what is a progression. So we are clear about what is a sequence, what is a series, and now we are talking about what is a progression. So how we will define a progression? So progression must follow a mathematical formula. For example, in the sequence, we were having what we have learned about the Fibonacci series or this Fibonacci sequence that was 0, 1, 1. Okay, we have done it in the previous slide. So there was no mathematical formula to define what will be the next term. But in a progression, there is a particular mathematical formula which will define our nth term, and it will be always followed. So those sequences whose terms follow a particular pattern are called progressions. Now, is this progression, is this sequence a progression? So if we'll see that yes sir, it will be a progression because the nth term is given by n. When you will write n equals to 1, you will get first term, n equals to 2, you will get second term, n equals to 3, you will get third term, n equals to 4, you will get fourth term, n equals to 5, you will get the fifth term. So similarly, when you will be putting the value of, if you need to find the 10th term, then n equals to 10 will give you the 10th term, that is 10.